Hello guys, welcome to the mathematics lesson. In today's mathematics lesson, we'll be looking at the shear transformation. Alright, we have already looked at so many types of transformations, such as the translation, we looked at the reflection, we looked at the rotation, we looked at enlargement, we looked at the stretch. Now we are looking lastly at the shear. Alright, so this is the last part of transformation. Alright, so without wasting much of your time, let's define what a shear transformation is. Alright, so here guys, we must understand that a shear is a transformation which keeps a fixed line, also known as invariant line, and moves all other points parallel to the invariant line and maps every straight line onto a straight line. Okay, so you are going to understand very well as we proceed. So in a shear transformation, you find that there will be an invariant line that we have already looked at in the other transformation, and then the points that are moved, other points that are not on the invariant line are moved. Okay, when they say a shear transformation is a transformation which keeps a fixed line, all right, moves all other points parallel to the invariant line. So it's like a transformation which will keep certain points fixed and then move other points of an object parallel to the invariant line. All right, that's what just this means. So a shear transformation is just a transformation which keeps certain points of an object fixed and move other points parallel to the invariant line. Yeah, I think this explanation makes sense, as you are going to see. All right, so for example, we have rectangle ABCD can be said to have undergone shear transformation into rectangle A prime, B prime, C prime, and D prime as shown below. So if we have a rectangle on a Cartesian plane like this, then we can say that this can undergo shear transformation if it changes to that position there. All right, with the new points like images like A prime, B prime, D prime, and C prime. So as you can see, according to the definition of a shear transformation, so there are points that have been moved, all right, parallel to a certain line. So like D and C have been moved in parallel form. All right, if I can reverse this one so that you see it is moving parallel to a certain line, and these other points remain fixed. All right, so such a transformation is a shear, or rather we can also say it as a twist. All right, so like this one becomes twisted, so these remain fixed and then these 2 points get moved like that. All right, so this is what it is. So we are saying A prime, B prime, D prime, C prime are the points of the sheared image. All right, so here let's move this one up. So here you must understand that also a shear factor concept come in, where we say shear or shear scale factor can now be found by distance of the image point from the object divided by distance of the object point from the invariant line. Okay, so you will understand what this means. All right, so in this case the invariant line is y is equal to 1. So the line to which this one moves parallel to is this line here, upon which these remain fixed. All right, and this again moves parallel to this. Right, so here it is very important to understand what the invariant line is. So the invariant line is a line in this case upon which the fixed points of an object remain when an object undergoes shear. So A and B remain on this line here while these moves. So that line upon which they remain fixed is what now we can call the invariant line. And this line crosses the y-axis at 1, and then we call it y is equal to 1 as the invariant line. Okay, so very important to understand these points at the beginning. All right, so we are saying now, having told you the invariant line, now we are going to explain this equation, or rather formula here. Okay, so this is y is equal to 1. So now what it is here is that distance of the image point from the object can be like this. So we can pick like d prime. Like this is the object and this is the image. When we say distance of the image point from the object, so like this image point from the object point is this distance. So if you get this distance d to d prime, then you divide it by distance of the object point from the invariant line. So the object point is this. We are dealing with this object point here from the invariant line, which is a. So the distance perpendicular from the invariant line, you pick the distance perpendicular. So this distance d from the invariant line y is equal to 1 perpendicular is along AD. So you divide by AD. So you measure AD. So when you divide that, then you are able to find the invariant, the shear factor of this transformation. All right. So it is distance of the image point from the object. So this is the image from the object. You can also pick this. If you pick this and this, all right, like let me just do this. Like if you say this is the factor will be equal to, so you pick like c, like you pick like c prime, then over, then you say c over b. So c b c. So this also can give you the shear factor. All right, so as long as you are picking first of all the distance of the image point from the object point, you measure this distance here, then you divide it by the distance of the object point from the invariant line measured perpendicularly to the invariant line. So you cannot say AC because this line here is not perpendicular, so you pick BC because C is perpendicular to the invariant line through this line BC here. Okay, so now let's move. So this is how we find the shear factor here. All right, so in this case we can even continue finding it if we say equals like d here, d prime, we can say how long it is, like we count from here 1 2 3, so we put 3 over, like then from a to d here we count like 1 2, so you divide, so you say shear factor then is equal to like 3 divided by 2, like you have 1.5 as the shear factor in this example here. All right, so now let's look at performing a shear by construction. All right, just like we had in construction in stretch, reflection, rotation, and also stretch, also we have performing a shear by construction. So let's go straight into the example. So here is an example where we are told a triangle has vertices a2, 1, b2, 4, and c5, 3. A shear with a scale factor of 1.5 and the invariant line being x is equal to 2. Then they're saying find the coordinates of its points. Okay, so it has a shear factor of 1.5 and the invariant line being x is equal to 2. Find the coordinates of its image points. So using construction, before we find the image point, the coordinates of its image points, we need first of all to plot this triangle on the Cartesian plane. So solution, so bring the Cartesian plane, and then we'll start like plotting these points one by one. Okay, so what we'll do first before we do the plotting, we have been told that we have the invariant line x is equal to 2. So x is equal to 2 is here. That's where the invariant line is. So we draw the invariant line and label it like that. X is equal to 2. Okay? So you're seeing the steps the way they are moving. So the next part is to begin plotting. Like we plot this coordinate A, which is the 2, 1. So you are at 2, 1. This one here. So the point is here. You put this is point A. Then B, 2, 4. So you are at 2, 4 somewhere here. All right. So you put a point there, B. Then C, you have 5, 3. So 5 is here, 3 is here. You put a point there, you label it, then you draw a straight line joining these points using a ruler like that, like that, like that. After you do that, what follows next is to find the shear factor, because the shear factor is very important. It is going to help you to know how each image point is going to be transformed. Okay, so what you are going to do here is this. So you are just going to write the formula for shear factor. The formula is equal to, like, if this is the invariant line, remember by transformation, by shear we said a shear is a transformation which moves points, okay, which keeps points fixed and move other points parallel to the invariant line. Okay, so it keeps certain points fixed on the invariant line, and then it moves other points parallel to the invariant line. So which means if this is how the invariant line is, then B and A will remain fixed. Then it is this that is going to be moved parallel, either upward or downward. Okay, either this side or this side, parallel to the invariant line, like that or like that. So for us now to be able to find the shear factor using this formula, we must understand that it is this that is going to move. So if it is this that is going to move, it is going to form a new image point. So that new image point, where it is going to go to, that distance from the image point it is going to go to, whether up or down, then that distance between the image point and the object point, like this, the distance between the image point and the object point, like C and C prime, where C is going to be the next point, because this one is going to move. So that distance between these two, then divided by this distance, now the object point from the invariant line, like invariant line along, like if I say like BC, it doesn't mean I'll measure this distance like BC. Like I'll measure this distance from this point perpendicularly to the invariant line. So the distance here. All right. So then I'll say then the shear factor has been already given. All right. So yeah, here in this case we were provided the shear factor as 1.5. Now, what we are looking for are the image points. So we'll look for image point, the image point where this one is going to go to. So say equals, then we don't know where this is going to go to. So we'll replace as it is, then over. Then we'll just measure the distance BC, like from here to this line, the invariant line. We will not measure along that. We'll get a wrong answer. So we'll just measure along the perpendicular line to the invariant line. So from here we count like 1, 2, 3. This is the distance, which is 3 here. Then we can make C prime the subject of the formula. You know that. So it is going to be like C prime is equal to this 1.5 times 3, which is going to be 4.5. So this will simply mean that this is going to be moved from here to the object point parallel to the invariant line in that direction. Since this is positive, so it will go like that upwards. Okay, how many times it is going to be moved? 4.5. So you see that I don't have a space here to plot this 4.5, so I'm going to increase the space here like that. So now I will be able to count it from here 1, 2, 3, 4. 0.5 on the middle there and put a point there, which is C prime, which will be the image of this. Then from there, these will remain fixed. So I'll just join the point and there. So then, yeah, so these now will become like we'll have the image A prime here, and then we'll have a B prime here, the image. So now, since the question was like we find the coordinate of this image, so we are going to say the coordinates of the image are like A will just remain at the same time, point A prime 2,1, then B prime it will be like 2,4, like here 2,4. Then now C prime here, C prime is going to be at 5, so this is 5, then comma 7.5. So 7.5 meaning you move from here to where that point is like 1, 2, 3, 4, 5, 6, 7.5. Don't put 4.5 but 7.5, counting from the x-axis. Okay, so let's move to the next example. So before we look at that, we are going to look at performing a shear by matrix method. So we are done with the construction. That's how it is done. Then we go to performing a shear matrix, a shear by matrix method. So before we do that, we are going to do the driving of the matrix of the shear along the x-axis and also the y-axis. All right, so we are saying consider a unity square undergoing shear parallel to the x-axis and x-axis as the invariant line. Okay, so we are going to have the Cartesian plane drawn properly like that. Okay, then we'll have like a square, a unit square like that, with the coordinates like this one here and here, these 2 points here, very important. Now we are told that this unit square is undergoing a shear parallel to the x-axis, so it will go in that direction, it will be sheared in that direction, which means it will go like that. So it has been sheared parallel to the x-axis, and then these points that are fixed here that do not move lie on the x-axis, and that's why we are saying the x-axis is the invariant line again in this case. So now you find that the image of I, it will be just here, and then the image of J will be somewhere here. All right, so if we were to put all the object point and the image point into matrix form as we have been doing, like the image point here I, the image object point here is in 0, 1, 0, this point is 1, 0. Then now here, if it comes to this, all right, it is transformed to this image point here, which is I prime. This I prime is still 1, 0, because it is still at the same point fixed. Then if we go to J, the object point, the coordinates are 0, 1, then equals, then it has been sheared to this new position. All right, so this is the image point, which will have the coordinates 2, 1, so it will have 2, 1. So putting this as usual into matrix form, like this image object coordinate like 1, 0, like that, then these are also J like 0, 1. All right, so we put them like that. Then these also we put them into a matrix form, this image point like I, it has 1, 0, then J image point, it has 2, 1. So like that, we are saying this as usual becomes the matrix of transformation under shear. So we are saying in general, the transformation matrix under shear parallel to the x-axis with the y-axis as the invariant line. Sorry, so I have to correct something here. This is not true. Parallel to the x-axis and the y-axis as the invariant line. No, x-axis as the invariant line. Yeah, so it has been corrected. So under shear, So in general, the transformation matrix under shear parallel to the x-axis with the x-axis as the invariant line is given as shown. So now in general, the matrix, now we can give it like this. So have 1, then 0, then this one becomes the shear factor by which this transformation has undergone 1, 2. So this one is the shear factor. Like here we put k, so we put 1, 0, 1, 0, then this one k, then 1. We are saying where k is the shear factor. Okay, so this becomes the matrix of transformation, where in terms of under shear, when an object has been sheared parallel to the x-axis. Okay, so let's now do another example. We are also doing another example where now we are considering a shear. Okay, so consider a unit square undergoing a shear parallel to the y-axis and the y-axis as the invariant line. So we have this one as the Cartesian plane as usual, with these points there. Then we have this object here with the coordinate here I and j in object point. So if this one undergoes shear parallel to the y-axis, then it will move like that. So meaning it will be sheared in that order. So meaning this I will change, its image point will be here. J will remain, its image point will remain here. So as usual, we'll put the image point of object point of I, coordinate 1, 0, which gets transformed into image point there at 1, 2. So image point I prime there has 1, 2 here. So this one is at 1, 2. Then j object point 0, 1. Then it gets transformed to its object point, still at the same point, image point at the same point, which is 0, 1. Then again putting this into matrix form, like here it will have 1, 0, then j 0, 1. Then this produces like this one. I prime image is going to be 1, 2. Then j, it will be 0, 1, like that. So we are going to say again, in general, I'm going to correct again. Yeah, so in general, the transformation matrix under shear parallel to the y-axis with the y-axis as the invariant line is given as shown. So this one can now change into like 1k 0, 1, like that. So then we'll say where k is the shear factor. So this one, you use it when the object has been sheared parallel to the y-axis and parallel to the y-axis. This is the matrix of shear. Okay, so let's look at one example. So here we are told under a shear with the x-axis invariant, a square with vertices a1, 0, b3, 0, c3, 2, and d1, 2 is mapped onto a parallelogram with the vertices a prime 1, 0, b prime 3, 0, c prime 7, 2, and d prime 5, 2. Then they're saying find the shear factor. All right, hence find the shear matrix. So we need to find the shear factor first, and then we find the matrix. Okay, so what we are going to do here is this. We must understand that we were given the object point, or rather the object, which is a square with these points here. And then we were told that this was sheared with the x-axis as the invariant line. Okay, and these points were produced, or the new image was produced, and it's a parallelogram. Then they're asking us that we find the shear factor under which this got sheared or transformed by shear into this image. And also we find the shear matrix. So solution, so to help us, we must first plot this to see which line it went parallel to. So we will get the Cartesian, then we'll plot nicely like that. So put all the points, everything nice like that. Then we'll get the then we'll start plotting like you see, we'll start plotting the image point or object point a 1, 0, it's here, so label it as m. Then b 3, 0, so 3, 0 here, label it as b. Then c 3, 2, 3, 2 here, label it as c. Then d 1, 2, 1, 2, label it like that, and then draw it. So this is the square, the vertices. Then we are told that this gets sheared, all right, to these new points here to form a parallelogram. So find that a is 1, 0, so it is at 1, 0, the same. So a prime will be just here, then also b prime will be just here. You see b here 3, 0, even here 3, 0, so b prime, it will just be there. Okay, then we come to c 7, 2, so we'll go to 7, 2 here, so c prime. Then we come to d prime 5, 2, so 5, 2 there. Then we'll label it as d, then which will mean that this object got sheared in that way, like that. That's how it got sheared. So it got sheared parallel to the x-axis, all right, and at the same time the x-axis is the invariant line, because it is the line upon which these fixed points are lying. Okay, now in such a case, when they are saying find the shear factor, we'll just use the formula. Shear factor is going to be, so we'll get any of these points, like the distance of the image point from the object point. So like if I pick this one, I'll say d from here to there, which is d to d prime, over, then I'll say d a to d, like a to d, from the invariant line a to d, like that. Then I'll say here I will count, what do I have from here to here? I have 1, 2, 3, 4 as the distance, so I put 4 over 2. Then AD I'll say 1, 2, so 2, so I'll divide there, I'll get it 2. So that is our shear factor. So we are saying this is our shear factor. So we have found the shear factor equals 2. Then the next thing was like find the shear matrix. So the shear matrix is, since this is parallel to the x-axis, we'll get this one. The shear factor will be like this, 0, then here 2, then here like that. Okay, so what has happened here is, when you go to those matrices we formed, you find that we had like 1, 0. Oh my god, let me remove that one. So like we had 1, 0, then we had like k, then 1 here. So now since the shear factor has been found to be 2 here, k, so we substituted 2, pressed it there to form this matrix here. So this is the matrix that we are looking for, the shear matrix. Okay, so yeah, so next is your task. So this is the task, guys, that you're going to do, so that you submit your work for marking. All right, so for those interested in online lessons for mathematics at 6 kwacha per month, science at 120 per month, and biology at 60 kwacha per month. You can follow through this line showing on the screen so that you are added to the online group. All right, as for now guys, bye and see you in the next lesson.